Okay, so the next section is 6.3. We're going to look at just reintroduction of the graphs of the primary trigonometric functions, sine, cosine, and tan, and to look at how they would be made or what the key points would be using radians. This will be a quick lesson, so let's do this. For sine theta, once again, our key points were 0, 90, 180, 270, and 360 degrees. But because we are working in radians, those become 0, pi over 2, pi, 3 pi over 2, and 2 pi. And this will be the same function, so it'll be the same key points for both cosine and sine theta. And we will use them also for tan theta, but we'll get to that in a second. Now, when we have the sine function, just a quick sketch, there are only 3 key points we need to know for the y values. There's the height, the max point. There is the minimum point. And there is the middle. For the sine function, you start at the middle and you go up to the max. From the max, the next point, you're going to come back down to the middle, and then we're going to go down to the minimum, and then we're going to come back to the middle. It's the same thing. You start at the middle, go up, down, down, and up. Cosine theta is very similar. It has the exact same pattern. The difference is where you start. For the cos theta function, you start at the max. From the max, you come down to the middle. You go down, continue on to the minimum, and then go back up to the middle and finish off at the max. What does that look like, or what are the values that are affiliated with that when it comes to sine and cosine function? The middle is at 0, the max is at 1, back to 0, and the minimum is at -1. So the pattern is always 1, 0. -1, 0, 1, 0, -1, 0. But I prefer to use max, middle, and min, and we'll look at that when we get to transformations, but why I prefer this method rather than remembering the points themselves. So that is the sine and cosine functions. Let's plot these points. The key points that I want are the max, right, which is at 1, and the minimum, which is at -1, and then you have the middle. On my x-axis, I have 0, pi over 2, pi, 3 pi over 2, and 2 pi. So there's pi, 2 pi, and then I know the middle ones would have to be half of each of those. For the sine function, I start at 0. At pi over 2, I end up at the max, back down to the middle, down again to the minimum, and then back to the middle. So if we were to connect the dots, we're going to use dashed lines. Remember to curve along, and this would be our sine function. Actually, for this one, let's do a solid line. So that would be your sine theta function. To find the cosine theta function, same idea, except that we start at the max. So from the max, go to the middle, down to the minimum, up to the middle, and then finish off at the max. Connect the dots. And you can see that the same function, just shifted slightly to the right or left, depending on where you start. Now let's combine these with the tan function. So now, for the tan theta function, we recognize that tan is just sine over cosine. So for 0, tan theta would be the sine value divided by the cosine value. So for 0, sine is 0, tan is 1, cosine is 1, so it's 0 over 1, which is 0. For pi over 2, we have 1 divided by 0, which is undefined, so there is an asymptote. For the pi function, the middle is 0 over -1, which is also 0. 3 pi over 2, -1 over 0, which is an asymptote. And then at 2 pi, you have 0 over 1, which is equal to 0. So if you see the pattern here for the tan theta function, at 0, you have an x-intercept. Pi over 2 an asymptote, pi an x-intercept. Asymptote, x-intercept. Asymptote, x-intercept. Every interval of pi over 2. But now let's combine those and let's look at what that function would be. Sorry, what the graph of that function would look like. So we have pi and 2 pi. The y values are irrelevant when it comes to this, and you'll see in a second why. So at 0, we have an x-intercept. At pi over 2, we will have a vertical asymptote. Again, at pi, you have a 0. At 3 pi over 2, you have a vertical asymptote. It's very important if you decide to graph using my way, which is straight to the graph, that you remember that everything on the x-axis is based off of these 5 points. Everything. And then from there, we'll move everything around. Now, we have our function 0, pi over 2, pi, 2 pi. We have each of these points. What's happening at 0, at pi over 2, at pi, at 3 pi over 2, and at 2 pi. What we need to figure out is what's happening in between. So if we think about it, 0 to pi over 2, 0, pi over 2, pi, 3 pi over 2. 0 to pi over 2 is quadrant 1. Tan is positive in quadrant 1, right? So this function we know would have to come closer to the asymptote, be positive, and that way. I'm actually going to go ahead and go back 1 to negative pi over 2, because I know that is also going to be an asymptote. So that's actually, this is what the function looks like. So now from pi over 2 until pi, which is quadrant 2, I know that tan is negative. Therefore, this function will go down towards the asymptote. From pi till 3 pi over 2, quadrant 3, I know tan is positive. So it has to go up this way. And quadrant 4 is from 3 pi over 2 till 2 pi. That's negative again, so it will go down. So the tan function is just this function here, over and over and over again, with a period of pi, right? Because it goes from negative pi over 2 to pi, from pi over 2 to 3 pi over 2, a period of pi, and that's how the function would look like. Remembering that for tan function, you remember your key points, and then remember what happens with sine and cos. Or x-intercept, asymptote, x-intercept, asymptote, x-intercept, asymptote. There's a pattern in all of these functions. By definition, trigonometric functions are periodic, meaning they just repeat over and over and over again.